Hey guys, this is Mrs. Keith. I'm going to do notes today over equations of a circle and completing the square. We're going to remind ourselves how to factor first. If you have a quadratic in the form ax squared plus bx plus c, for example, like x squared minus x minus 12, that factors to be x minus 4 times x plus 3. Y'all have been doing that for a while now. We're going to talk about a special case, a perfect square trinomial that looks like this, a squared plus 2ab plus b squared, where your first and last terms are squared, and your middle term is the square root of those and then doubled. So, for example, this first one right here well, let me go back. When you factor that, the way it factors is the square root of this a squared is a, the square root of b squared is b. And when you factor it, it's going to be a plus b times a plus b. And we would end up writing it as a plus b squared. The a and the b come from the square root of those in terms. The plus sign comes from the fact that this is a plus right here. All right, so let's do an example. This first one is a perfect square trinomial because the first term is squared, the last term is squared. The square root of x squared is x, the square root of 36 is 6. This middle term is those two doubled. When you multiply x times 6, you get 6x, and when you double it, you get 12x. So this is going to factor to be x and 6 and x and 6. The sign that I'm going to put in the middle is whatever that sign is, so minus and minus. This is the factored form of this. So you get x minus 6 squared is how we would write that. Now, you guys could have factored that using your big X. You would have done your 36 and your negative 12. And the two things that you would get to multiply to be 36 and add to be negative 12 would have been negative 6 and negative 6. This is just an easier way to do it quickly if you see that it's a perfect square trinomial. On the next one, again, perfect square, perfect square. This is y, this is 5. This middle term is those two, the y and the 5, doubled. So this will factor to be y plus 5. It's plus because of this plus sign, times y plus 5, which is the same thing as y plus 5 squared. All right. The reason why we need to do that is because that's just the way a circle equation is going to end up looking. And so that's why we need to see that. All right, on the next one, the area of a circle is 49 pi inches squared and wants to know what the circumference is. Well, we know our circumference formula is 2 pi r, which means I need to know what the radius is. I don't know it, I know the area, but I do know the area formula is pi r squared. So I'm going to plug in what I know, plug in the area in where a is, and I'm going to solve for the radius. I'm going to undo the things that are being done to the radius, like being multiplied by pi, divide both sides by pi, and the pi's cancel. So now you have the radius squared equals 49. All right, we need to unsquare it, so we take the square root. Remember, when you take the square root, you get a plus or a minus, but we're going to only do the plus because we're talking about a radius, and a radius can't be negative. So my radius is equal to 7 when I take that square root. Now I can find the circumference. So circumference is 2 pi times 7, which is 14 pi. And using my inches for my units, that's my circumference. All right, another thing we need to make sure we remember how to do is find the distance between 2 points. And we've been doing this since the beginning of the year. But if you'll recall, our formula looks like this. I hate to write that formula all the time. So I told you guys that you can just think of it as the change in x squared plus the change in y squared. So if I'm finding the distance between these 2 points, my x's change from 4 to negative 6. That's a difference of 10. So we'll put 10 squared here. My y's go from 4 to negative 2. That's a difference of 6. So we'll put 6 here. That's getting squared. All right, so when I add those together, 10 squared is 100, 6 squared is 36, so this is going to be the square root of 136. Simplifying this, a perfect square that's in 136 is 4. It's 4 times 34, so this simplifies to be 2 square root of 34, and that would be my exact answer. All right, locating the midpoint. Remember, our midpoint formula is the average of our x's, so we add our x's together and then divide by 2. And then the average of the y's. So we add our y's together, divide by 2. So in this particular case, we'll have 10 plus a negative 4 divided by 2, and 6 plus 14 divided by 2. That gives me 6 divided by 2, which is 3, 20 divided by 2, which is 10. So my midpoint is at 310. All right, those are going to help us here in a minute when we start doing some of these circle equations. All right, the equation of a circle. This is the plain Jane generic form of the equation of a circle. X is squared and so is y. If the center is at 0, 0, it looks like this form. X squared plus y squared always equals the radius squared. You know how to find the center. We've been doing that for a while now. Your radius is the distance from the center to a point on the circle, which in this case happens to be 3. So when we write the equation of this circle, we're going to write it as x squared plus y squared equals 9. All right, that again is when the center is at 0, 0, that we have it in that form. So let's move it off of the origin. Let's translate it a little bit. So this next example has the exact same circle, it's just moved. You can see your center is right here, and it's moved from the origin that was right here. So if we think about this in terms of how it translated, it went to the right 2 and it went down 3. So it went right 2 and down 3. All right, so looking at your equation that goes with this circle, let's talk about how we can see that translation in the equation. We went to the right 2, and that's shown with this right here. So that's the right 2. We went down 3, and that's shown with this part right here. It's kind of opposite of what you think. I mean, right had a minus sign, down had a plus sign, but that's the way it's going to always be. It's opposite of what you think inside your parentheses. My center then is now, I can tell it's now at 2, -3. So what I want you to notice here is that your x squared became x minus 2 squared because we went to the right 2, and my y squared became y plus 3 because we went to the left. I'm sorry, my goodness, because we went down 3. All right, so this is the standard form for the circle equation. You'll have x minus h squared plus y minus k squared equals r squared, where h and k is your center, and your radius is whatever this is when you take the square root of it. So let's do some examples. In this case here, we've got, I'm going to rewrite the formula real quick. X minus h squared plus y minus k squared equals the radius squared. So it's x minus whatever the x value is of your center. So we've got a plus 4 right here. It's always opposite sign. So I know my center has an x value of -4. The y value, it's y minus 5. So my y value for my center is 5. So I'm going to plot that point. I know my radius, remember this is radius squared. So I know my radius is the square root of 36, which is 6. So from the center, I'm going to go out 6 units. I'm going to do it left, right, up, and down to get 4 good points. All right, now I'm going to try to connect the dots as best I can. So that's the circle with the center at -4, 5, and a radius of 6. All right, on the next example, they gave us the center and they gave us a point on the circle. So again, I'm going to write it in that form. X minus h, the h is the x value of my center, so x minus 2 squared plus y minus 4 squared equals radius squared. I don't know what the radius is. What I do know, though, is a point on the circle. So I can plug that in for x and y. So I'll say a -3 minus 2 squared plus 16 minus 4 squared equals the radius squared. That's a -5 plus 12 squared equals the radius squared. That's 25 plus 144, which is 169. Now that equals the radius squared. And remember, in your equation up here, you need the radius squared. So I need that 169 in my equation right there. If I actually ask you for the radius, it would be 13, but that's not what we're looking for here. We're looking for the equation. So we would write it as x minus 2 squared plus y minus 4 squared equals 169. And there's your equation. All right, on the next example, this is another way for us to ask you. We will give you the diameter with its endpoints. My diameter's endpoints are at 3, -2, and -3, 6. I need to know the equation of the circle that has that diameter. I know the center should be halfway between those 2 points, and that's why we talked about the midpoint in our warm-up earlier. So remember, we did x1 plus x2 divided by 2, y1 plus y2 divided by 2, because we can find the midpoint between those two endpoints to figure out where the center is. So we would do 3 plus -3 divided by 2, -2 plus 6 divided by 2. That's going to be 0, 2, which is right here. Now that's one way to do it, to find your center. Another option is to count. I went from this point right here, I went down 8, and I went to the right 6. You're going to do half of that, so you'll go down 4 and to the right 3. So if I go down 4 and to the right 3, I still end up right here at 0, 2. So just another option. Okay, now when we write our equation, I'm going to say x minus 0 squared plus y minus 2 squared. I still need to know what the radius is. Well, I know the length of my radius should be the distance from my center to an endpoint of the diameter. So I can calculate that using the distance formula. That's why we talked about that earlier. Remember, that was change in x squared plus the change in y squared. So my radius will be, we already know the change in x and the change in y from my center to an endpoint. So it'll be my x is changed by 3, my y is changed by 4. So my radius will be, that's 9 plus 16, which is 25. My radius is 5. So now we can write the equation of our circle. Instead of writing x minus 0 squared, I'm just going to say x squared plus y minus 2 squared equals that 25, the radius squared. And that's the equation of our circle. And so what I kind of also want you to see here is that the x didn't have, it had a 0 for the value of the center, and so it didn't have anything added or subtracted there. All right, on the next example, we have a point on the circle, 4, 3. So I want to know if it's actually on the circle. Well, right now I know the equation of this circle. It's at the center, so the center's at the origin, so it's x squared plus y squared equals 5 squared, so 25. My radius is 5 right here. I want to know, does that point lie on the circle? That's an x and a y that I can plug in to see. So is 4 squared plus 3 squared equal to 25? Well, it is. So that means that that point is actually on the circle. All right, next, we need to know the difference between writing an equation of a circle in general form versus standard form. We've been doing it in standard form. And remember, that was in the form x minus h squared plus y minus k squared equals the radius squared. We need to know how to do it in general form, which looks like this. So I'm going to kind of walk you through this one example that they gave us. You remember when you're multiplying a binomial, or you're squaring it, you're multiplying it by itself. So you've got to remember to FOIL that. You've got to do x times x to get x squared, x times a -2, -2 times x, and -2 times -2, which is 4. And then you've got your y squared plus x. Oh, I keep doing that. Plus y plus 1 equals 9. When you write it in general form, you write your biggest degree terms first. So the x squared and the y squared get written first. Then you combine your like terms. You've got a -4x. You've got a negative or positive 2y. I'm going to add the 4 and the 1 together to get 5, and that equals 9. Now this, when it's in general form, it should be equal to 0, so I need to move the 9 over. So it's x squared plus y squared minus 4x plus 2y minus 4 equals 0. All right, now let's do completing the square to go backwards, to change it from general form to standard form. So what we'll do is follow these steps that are written here. I'm going to group the x's together first. So x squared minus 2x, and then the y's together. There's only a y squared. Move over the 8. And then what you're going to do is make it where it's a perfect square trinomial. So you're going to have x squared minus 2x plus something to make it a perfect square trinomial. It has to be a perfect square. Y is already taken care of. It's just y. Well, I don't want to change the equation. So what I do on the left, I have to do on the right. So what you're going to do is take this middle term, that -2, you're going to divide it by 2, and you're going to square it. So that gives me a -1 that gets squared, which is 1. So what you're going to add to both sides is 1. So here, when you factor it, it's going to factor to be x minus 1 times x minus 1. Again, this right here is what's going to go inside those factors. It just works out that way every time. Plus y squared equals 9. So this is x minus 1 squared plus y squared equals 9. What I did was I factored this to get this. And we factored it so that, or we forced it to be where it would factor to be a perfect square trinomial. So this is the equation of the circle. Now I know the center is at 1, 0, and my radius is at 3. All right, on the next example, we'll have x squared minus 4x, grouping your x's, y squared minus 6y, grouping my y's, equals -8. All right, I've got to add something to both sides to make this a perfect square trinomial. And this time I have to do it for both x and y. So to get that number, we'll have -4 divided by 2 that's getting squared. And that's going to be a -2 that's getting squared. So it's 4 that we're going to add to both sides. And then on the y, we'll have -6 divided by 2 squared, which is -3 squared. So we're adding 9 to both sides. So this ends up factoring to be x minus 2 squared. Again, that ends up being what's in here every time, plus y minus 3 squared, which was that. And then it equals up here, it's 5 when you combine that right-hand side. So now I know my center is at 2, 3. My radius, remember, is this was the radius squared. So my radius is the square root of 5. All right. The rest is in-class practice, so I'm going to let you practice that on your own, and I hope you'll have a great day. Thanks. Bye-bye.